So here we're going to examine how to insert data records once we have created the table. For that, we're going to use the insert statements. And the insert statements are kind of straightforward. So there's the keyword insert and into. And once again, it doesn't have to be capitalized. It's not going to be blue. It doesn't matter the color. But there is a space here. So they don't go together. There is a space, and the spaces are very important. Here's the name of the table where you want to add, and then you open the parentheses and you identify the attributes that you're going to use. Now, sometimes you don't need this, but because I'm not adding to all of the attributes, I want to be specific about the attributes that I'm adding to. So I'm going to add the ISBN, the year published, the title, author, publisher, and date acquired. I'm not adding the book ID. So this is actually a picture of the structure of the table. I'm not adding the book ID because what I noticed is that when I added the book ID, when I created this table, I actually made the book ID auto increment. So you would automatically increment. And if we go back to those previous statements, that's actually something that we can add over here, or even for this one patron ID here, we add the auto increment here. You can kind of look that up too, and I may show this elsewhere. You can add the auto increment here as a keyword, and I'll show you elsewhere how to do that. And you can also look it up in the other sources online. So because I add the auto increment, when I add data into the table, I do not want to add the book ID. I want to let the program add the book ID by itself. It just adds a new random number. So I'm just going to add the ISBN myself, the year published, the title, the author, the publisher, and the date acquired. Notice that this order does not have to match this order. But this order does have to match the order of the values too, because it has to match here. But here, and then it figures out what goes where. So you add the attributes, close parentheses, then space, I add the word values, that's the keyword, space, open parentheses, and then the ISBN number, in this order, ISBN number, the year published, the title, author, all the way over here. This is the full name of the title: Economy, Society, and Lordship in Medieval Poland, 1100 to 1250. Author, publisher, this is a publisher name, and then date acquired. Now notice that I have quotes around it. And that's because for every character data type and also the date data type, I need this quotes around it. And actually, I need a kind of special quote. It's like a flat quote. Now, if you actually type this up on the SQL window, you can just type a single quote on the keyboard, and the single quote should be this one. But depending if you're using a different program, you may have like a different quote, like a curly quote like this, and that may or may not work. So you can try it to see. Notice that this is a long number integer. It looks like an integer, but we didn't make it an integer, the ISBN. The ISBN is character, so it's like a text, even though we can use these numerals. So for all the text and all the character data and all the date, we need the quotes around it. That's how it knows that this whole thing is the name, because the quote begins here. Then you can add everything in here. And then once you finish the quote, you know that the value is done. And then you put a comma, and a comma means the next refers to the next attribute. So this is the author, see the quotes, publisher quotes, they're all characters. Year published, notice year published, no quotes, that's because it's integer. So don't need it. Also the format, remember the format has to be year, month, day. And then after the semicolon, if you want to add another record, you can just repeat the same statement, but keep the attributes that you need, but also add the different values, the different record itself, and you kind of repeat that to add more records. Just some notes here for you to remember. So order of fields does not have to match order in table, but of course it has to match the order within itself. Value need to match data type of field. So if this is an integer, then you don't need quotes, and you should not have quotes, and this should be an integer because year published is integer, so thus has to match. So this is why it's good to look at the structure of the table when you insert the data. Use single quotes around character data, also date data as well. Data must have single quotes around it. This is the format. Integers do not need quotes around it. Auto increment fields do not need to have values added. So if you're not gonna, because if you have auto increment, you don't add it. If you don't have auto increment, you might want to add the book ID here because that's probably not known and you need it. Once again, just another example here, but now adding to the loan table. Now remember that the loan table is based on the loan ID, the patron ID, book ID, loan date, due date. The loan ID is also auto increment. So I'm not going to add the loan ID, but when you add the patron ID and the book ID, notice that I'm adding the IDs itself and not the names of the people, because the names and all the information about the patron and the books are in the patron table and the book table. So all I need is the ID, because then the ID, I can connect to that table and get that information. Querying databases. So we've been talking about the data definition language and creating databases, but now we're going to see how to retrieve information from databases. And I use an example here that I hope will help clarify what's going on when we take these actions. All of database manipulation is done via SQL. However, much of SQL and database interaction is via selection of data and the use of select statements. Select statements are used to retrieve and filter and reorganize data based on various parameters. And it's very structured language, as the name suggests, but so it's kind of similar to other searches you may do on, for example, on a retail website, but not exactly the same. But to take the example of, for example, searching for some item on a website like a shirt, if we translate that to SQL, and maybe some of these programs actually have to translate that to SQL, it would be something like this. Select ** means all the fields available from the items table where category like shirt, and this is the wild character. So where category has the word shirt in it. Wild character. And these are the parameters: size, color, department, category. I don't really know how this one site uses that information, but I use it here as an example so you can see kind of how the select statements for databases would apply in a kind of common application like a online retail store for searching for information. SQL select is not a natural language search function. It is highly structured, but it can be used in conjunction with one. So often when there's a search box in these websites, you can add anything you want, but where do I go, or like blue pants. So the application has to figure out how to search, how to use this information, maybe plug that into a more structured select statements, and then go in the database and retrieve the items, the records. Each of these is a record, right? If you can tell, this is one record of this green shirt, the blue shirt, the pink shirt, and so on. So here I'm going to give you some more examples of the limited scope of the work we're doing in this course. So we have the table that we're talking about. This is the table structure, the table schema. And here's an example of querying the database to select all the patrons' phone numbers. So we have the select keyword first, then we list the attributes we want. If you want just all the attributes of the patron table, then you can just use the asterisk instead. But if you want just some attributes, you identify them, and you separate them by comma. After the last one, you don't need a comma. And then the keyword from, and then the table where they're coming from in the semicolon. And that will retrieve all the records from the patron table. If you want to select all the books with title Economy and Society, well, you have to select if you want all of the fields, all of the attributes from the book table where title equals Economy and Society. So title, one attribute, one parameter here. Now, probably not many books have the same exact name, probably more than one, but not many books have the same exact name. So if you know the name, this is how you would search for the exact name of the book. Now, if you don't know the name, you can use that keyword like, and that searches all the titles that have the word economy in it, followed by anything, once again, wild character, followed by anything and preceded by anything else. And then also here we have this, it's called Boolean operator. And what this means is that it's this query, this instruction, these are essentially all instructions, is going to retrieve the books where the title has the word economy in it, or the title has the word society. So the search is not looking for the books that have title, certainly it's not actually looking for this here. It's not implementing exactly what this is written here in English, but it's looking for the titles that have the word economy or the word society, and maybe not both at the same time. If you wanted to change that, you could instead have maybe, instead of and, you write the word, instead of or, you write the word and. So you want the books that have the title, the word economy and society in the title. That's how you would search for that. Selecting all loan information for a particular patron. So if you want to select all the loan information for a particular patron, you would do select all fields from, after from keyword is always the table name that you want to select from. And then where is the conditional parameter. Patron, you got to identify the attribute that is going to be restricted or filtered, equals 1. And notice how, because we're searching by patron ID, we need to put the value here as patron ID. We cannot just put anything here. It has to be a value that actually exists in patron ID. Otherwise, we're not going to find anything. Now, if you didn't know the patron ID and you wanted to search for it by name, we actually have to join the loan table with the patron table. Look, notice that the loan table does not have the patron name on it. So if you're searching for loan information for a patron by name, you need to connect these two tables, which we can't do because the name of the patron is not in the loan table. So we cannot just search the loan table by itself. We need to join them. So we use the join statement, the join keyword, and the structure is like this: select all the fields from table name, join the other table name on, so there's another keyword here, loan.patron ID. We have to identify the both the primary key and the foreign key that connects them to. And it's this one here and this one here. Notice how they, and this in this model, he ended up written differently. So patron ID from patron doesn't have the underscore. Here it has the underscore. So we got to make sure that this is correct. And I want to be specific. So I put loan.patron underscore ID. See loan, this table name dot attribute name. This is the, let's say, full name of the attribute. And when you do this to avoid ambiguity, computers hate ambiguity. So we're going to be very precise. Equals patron dot patron ID. So here it doesn't match this model, but I think it matched the way I implemented. Always got to look out for these kind of little mistakes because they're hard to perceive, but they will stop your program from working. So this is how you join two tables. And once you join these two tables, then you can look for the loan information based on the name. Essentially, this statement, this join statement here, join on, puts these two tables together, and then you can search all of these attributes available across the two tables. So you can search the loan information by using the name of the patron. So last name equals Pan and first name equals Jan. I have somebody called Jan Pan here. So this is how you identify all the loan information from where the patron is named Jan Pan. And you can apply all of these, right? I'm going to show you later how to implement all of these to actually search your database. And you can copy and paste, type this out on your own once you have created your own database, and then you can search for and explore. There are all kinds of things we can do with SQL, way more than we could cover in one single entire course. So another things we can do is calculation. So for example, if you want to select total cost of all books combined, so we have a cost attribute here in the book table. So we can select the sum. This is the function. This is a function, a built-in function that it has. It's a function, and because it's a function, our functions are always going to have parentheses like this. And this, of course, this is the attribute name that I got from here, from the book table. So from this is the book table. So select the sum of the cost from the book table. So it's going to sum all the cost of all the books and give you the total sum of all the costs. Another thing we can do is select total numbers of books available, and that's we can use the count for this. So we count the book ID. Book ID is the unique. So the count of book ID is essentially the count of the unique books we have. An interesting function that you can use probably is the average cost. What's the average cost of all the books? Well, it's very easy to do. Just select average cost from the book, type it in, you run the SQL query, and it gives you the average cost of all the books. Now, getting a little bit more complicated, but just to wrap up, here we have a little bit more of calculation. So for example, imagine if you wanted to select the time, like the number of days it takes each loan to be returned. So notice that in the loan table, we have the loan date, the date the item was loaned, and we also have the return date, and we have due date too. And I kind of, in my older example, I had only loan date and due date, so I used that, but I think it makes more sense to use return date. So what I'm trying to do is identify the difference between the loan date and the return date. I want to know how long it takes for people to return the books. Is it usually like 5 days? Is it usually 3 months, and so on? So I want to get the difference between the loan date and the return date. Now, I kind of thought I could just subtract loan date from loan date to return date, but that might not work. So I'm using this function here. So let's go over this whole instruction here. Select all of the fields. Also, so comma, select also the date difference. So this is a function, another function. And how do I know this function exists? Well, I just looked it up and to try to find a function to find the difference between dates. And this is what came up. So date diff, open parentheses. Now these are the parameters or the input for the function. And to understand how the function works, you need to look up at the manual. And it's not, we don't write due date minus or dash. You just write with a comma. You just write the two things that you need to get the difference from. So that's loan.dueDate. So loan.dueDate. I'm sorry. So this should be like loan date. So loan-date. It doesn't matter because I use like a different one here anyways, but it's important that you get the idea. So loan.loanDate and the loan.return date. So this function is going to return the difference between these two values. And here there's another new SQL keyword as days to return. So you can give a name to the thing that comes right prior to it. And this is kind of shown over here from loan table. So the result of this query is going to be all of the fields here from the loan table, and then plus a new one, comma, a new one. So this whole thing here goes together. This whole thing is like one. And then days for return or days to return. And it's the difference between the two values that were added in the function. So 92, this is 92 days. So when I computed, I just took the difference between loan date and due date. But it might be more interesting for you to look for the loan date versus the return date. The due date is going to be always the same, like, 3 months from the loan date, but the return date is different for everybody. And also you can do other things too. For example, get the average of the difference. So you can select average, you average out, which is so this is kind of like a function without a function. It's like Inception, that movie you may have seen. So the way it works is loan date, select the average, date difference. Now here should be only one parenthesis, not this one here, as average days to return, close parenthesis here for the average. So this all of this here should be within the average. The average this whole thing out. Now actually I don't know, we can kind of play around with it. Actually I'm not really sure if this goes here or not, or goes here. you got to play around with it. Actually, it might make sense to put it here. Actually, both could work. So here, as average days to return, this as refers to the average. So average day difference is good. This function is going to average the difference of all the dates in the records. So notice we don't have an average here, and we just list for every record. We have this one loan here took 90 days. This other loan took 92. This other loan took 92. This loan took 90. This loan took 90. If we do an average, we're just going to sum. We're going to average out everything. So the result here is going to be one value, like 90.1 days or something like that. And that's another example of how to manipulate the database. You can kind of just copy this and plug it in yourself and see how it works. Here's just some basics of SQLs to summarize. Also look up further information online. And that's it for this one.